Enterprise AI deployment today is marked by a fundamental tension. Organizations recognize the need for sophisticated language models to drive innovation, yet they frequently recoil from the immense infrastructure costs and high energy consumption associated with frontier systems. These traditional large language models, LLMs, often demand dozens or even hundreds of graphics processing units, GPUs. This massive infrastructure requirement creates substantial electricity consumption and operational cost barriers, rendering large-scale AI deployment impractical for many businesses. For enterprises operating in markets constrained by power infrastructure or tight operational budgets, these barriers effectively eliminate AI as a viable option. A lightweight solution emerges. NTT has provided a practical resolution to this constraint with the launch of tsuzumi 2, a lightweight large language model. Crucially, tsuzumi 2 is engineered to run effectively on a single GPU. Early deployments of this model have already demonstrated performance that matches larger, more resource-intensive models, but operates at a mere fraction of the usual operational cost. This focus on the performance-to-resource ratio is key, as the total cost of ownership is the central driving force behind AI adoption decisions for many enterprises. NTT characterizes the model as delivering world-top results among models of comparable size, specifically in Japanese language performance. Its particular strengths lie in business domains requiring knowledge, analysis, instruction following, and high safety standards. Domain specialization and language focus. For businesses operating primarily within Japanese markets, this optimization for the Japanese language significantly reduces the necessity of deploying larger, multilingual models, which inherently demand substantially more computational resources. Furthermore, tsuzumi 2 incorporates reinforced knowledge tailored to financial, medical, and public sectors, developed directly based on customer demand. This built-in domain expertise allows for specific industry deployments without requiring extensive fine-tuning efforts. The model also supports essential capabilities like retrieval-augmented generation (RAG) and fine-tuning. These features enable the efficient development of specialized applications for enterprises, holding proprietary knowledge bases or dealing with industry-specific terminology, areas where generic models typically underperform. Case study: addressing data sovereignty at Tokyo Online University. The practical considerations driving the adoption of lightweight LLMs are clearly illustrated by the deployment at Tokyo Online University. As is common within educational institutions and regulated industries, the university maintains a data sovereignty requirement, operating an on-premise platform to keep student and staff data securely within its campus network. After rigorous validation confirmed that tsuzumi 2 was production-ready for complex context understanding and processing long documents, the university proceeded with deployment. Its applications include enhancing course Q&A systems, supporting the creation of teaching materials, and providing personalized student guidance. Because the model operates on a single GPU, the university successfully avoids both the high capital expenditure associated with purchasing GPU clusters and the substantial ongoing electricity costs. More critically, the on-premise deployment directly addresses data privacy concerns that often prevent educational bodies from utilizing cloud-based AI services that process sensitive student information. Security, compliance, and Asia-Pacific market drivers beyond cost savings. Data sovereignty is a major business driver for lightweight LLM adoption, particularly within regulated industries. Organizations dealing with confidential information face significant risk exposure when their data is processed through external AI services that may be subject to foreign jurisdiction. NTT markets tsuzumi 2 as a purely domestic model, having been developed from scratch within Japan and designed to operate on-premises or within private clouds. This architectural positioning alleviates concerns surrounding data residency, regulatory compliance, and information security issues that are particularly prevalent in Asia-Pacific markets. Integration with existing enterprise workflows. The partnership between Fujifilm Business Innovation and NTT Docomo Business exemplifies how enterprises can integrate lightweight models with their existing data infrastructure. Fujifilm utilizes its Array-AI technology to convert unstructured corporate data such as contracts, proposals, and documents containing mixed text and images into structured information. By integrating Tsuzumi 2's generative capabilities, advanced document analysis becomes possible without the necessity of transmitting sensitive corporate information to external AI providers. This architecture, which couples lightweight models with on-premise data processing, offers a pragmatic enterprise AI strategy. It effectively balances the need for robust capability with critical constraints related to security, compliance, and cost. Multimodal capabilities for business complexity. An essential feature of Tsuzumi 2 is its built-in multimodal support, allowing it to handle text, images, and voice inputs within enterprise applications. This is significant for business workflows that require AI to process multiple data types without relying on separate specialized models. Workflows such as manufacturing quality control, customer service operations, and document processing frequently involve combined inputs of text, images, and sometimes voice. A single model capable of handling all three data types significantly reduces integration complexity compared to managing numerous specialized systems, each with unique operational requirements. Market context and strategic implementation. NTT's lightweight strategy stands in contrast to the prevailing approach of hyperscalers, who emphasize massive models offering broad general capabilities. While frontier models from companies like OpenAI, Anthropic, and Google offer cutting-edge performance for organizations with substantial AI budgets and highly advanced technical teams, this strategy excludes a significant segment of the enterprise market. This excluded group is particularly large in Asia-Pacific regions, where the quality of infrastructure varies. Lightweight models enable on-premise deployment, which better accommodates these regional variations, including differences in power reliability, internet connectivity, data center availability, and diverse regulatory frameworks compared to approaches demanding consistent cloud infrastructure access. Organizations evaluating lightweight LLM adoption must consider several factors. Domain specialization. While Tsuzumi 2 excels in reinforced knowledge for financial, medical, and public sectors, organizations in other industries must carefully assess whether the available domain knowledge meets their specific requirements. Language considerations. The strong optimization for Japanese language processing benefits organizations focused on the Japanese market, but it may be less suitable for multilingual enterprises needing consistent cross-language performance. Integration complexity. On-premise deployment demands internal technical expertise for installation, ongoing maintenance, and necessary updates. Organizations lacking these internal capabilities may find cloud-based alternatives operationally simpler, even if they incur higher costs. Performance trade-offs. Although Tsuzumi 2 matches larger models in certain specialized domains, frontier models may still deliver superior performance in highly novel applications or complex edge cases. Enterprises must determine if domain-specific performance is sufficient, or if the broader capabilities of massive models justify the elevated infrastructure costs. Conclusion. The practical path forward. The deployment of NTT as Tsuzumi 2 clearly demonstrates that achieving sophisticated AI implementation does not inherently necessitate hyperscale infrastructure, particularly for organizations whose requirements align with the capabilities of a lightweight model. Early enterprise adoptions are already showing tangible business value through reduced operational costs, enhanced data sovereignty, and reliable, production-ready performance within specific domains. As enterprises continue to navigate the complexities of AI adoption, the inherent tension between required capabilities and operational constraints is increasingly driving demand for efficient, specialized solutions, moving away from general-purpose systems that demand extensive infrastructure. The key question for organizations is not whether lightweight models are objectively better, than frontier systems, but whether they are sufficient for addressing specific business needs while simultaneously solving the cost security and operational hurdles that render alternative approaches impractical. The success of early deployments, such as those at Tokyo Online University and Fujifilm Business Innovation, suggests that the answer is increasingly a resounding yes.